assess environmental performance in buildings. How could we use that, or parts of it, as a teaching tool for our students? Because it's a very complex program, and for student education needs, we really were interested in trying to use bits of the program to explain and develop ideas around environmental principles that students could use themselves in developing their designs and and be able to model this and see how the effect of different factors in terms of building design could be influenced depending on how large windows were, for example, or the kind of materials. Right, so we're going straight into the slides at this point. Right, so what we thought was, as I said, could we strip down IES? The original idea was to strip down IES and come up with IES Education, a teaching tool. We did find that within our limited budget and timescale, that was far too ambitious. So it was to do with looking at what the factors were, what bits of IES we could use to develop a future teaching tool. And what we really pretty soon started to organize ourselves around was to put together what will be called a beta model, which would be a kind of student worksheet where the students could work by themselves or with their lecturers to go through different parts of IES to look at, to investigate parts of environmental issues that they need to deal with in their design work. So the first thing we did was to identify what those key themes were, and then we had a discussion or thought about how it would be best to get students to interact with these themes within the model structure. And then finally the issue was to do with who were the other stakeholders. So it wasn't just the students, it was going to be the lecturers. It was also going to be possibly talking to small and medium enterprises, that's small architecture firms and so on as well, to see whether in developing what was going to be a teaching tool, it might also have a continuing professional development aspect as well that could be developed. Okay. Right, so we therefore went on to identify the themes. The key themes we looked at were climate, just the general climate and situation, lighting, because IES has a very full lighting area, like a set of lighting tools, and then very basic thermal analysis, really focusing on the idea about using IES to its potential. So it was a dynamic model we were going to use, but for the students' requirements, it was really to assume a passively conditioned building. So we assumed everything would be in normal, would have no technical inputs. So the building would not have any heating or any other forms of energy. So we think about the building being just a steady building in its own sense, and we'd see how the environment using the IES system would moderate how the building's comfort level was inside. But we'll discuss that further when we get to that slide. Right, so those were the key themes: climate, lighting, thermal ventilation analysis, and it was in the dynamic mode, as said. Right, so what we had to do was to develop the IES beta worksheet, and then we went on to present some trial sessions which involved myself going to 4 schools of architecture and soliciting information and feedback, mainly from the staff at this point, but also gaining access to use their students in future to do some testing of the beta program that was subsequently developed. Right, so what is the IES program and what does it do? Well, effectively it's a modeling program. It can model the way and the environmental performance of a building will, how a building will perform environmentally by taking in a building model and then running a series of simulations, environmental simulations. Now, for the purposes of architecture and architects, as I said, the themes we were really interested in was just looking at what effect climate had on the model, what effect lighting would have, and then, as I said, basic parts of the thermal environment of the model. So what one has to do with IES to begin with is to think about your model, design your building, bring the model, design your model in terms of using a 3D program. For example, we use mainly Google SketchUp. There is actually a model within IES that could be used called Model It. But again, because we were looking at the needs of students and a very easy system that they were already conversant with, what we used was the Google SketchUp system. So they were to design their own model and bring it in. But again, because we were designing a beta program ourselves, what we did was to do a set of basic models that they could simply import. So the idea was to import that model into IES, and on the screen you can see the original model there, and then in IES this is what it looks like. So this is the model that will be used for the different simulations that were being used at different times. So if we go on, the first was a set of climate tools that are within IES. Now, we used two of the climate tools. One was the climate matrix, which has to do with running climate files, climate data. If we look to your left here, you can pull down the tab within IES, and you're able to actually define a climate, or rather there are climate files for specific countries or specific locations in specific countries. And so, for example, for Edinburgh, the location of the actual climate information, I think, is somewhere in Dundee, possibly, but to a large extent, to the nearest location of the city or place, you can get some climate data. What we decided for the final program was that we would actually give very specific places, because there's an issue about whether it's the actual climate for the area. It's not quite the same as taking down your BBC weather data for Edinburgh, but it's close to. So you have that, you're able to get into those climate files, load the climate files, and then you can do what's called a climate matrix analysis. Now, unfortunately, we don't have this in large scale, but what it does is to show you what times, if you're building in that location, you're likely to need more cooling, what times you're likely to need more heating, and also how the building in that location can be compared to buildings in other locations. So you find out what the characteristics are. So for example, using Europe again, or the UK, it's a maritime climate. There's lots of rain, surprise, surprise. But also there are issues around when you can, if you like, deal with not having to have full heating and not having to have full cooling. For the students, it's more a visual viewpoint, because we're generally at the stage at which we're developing the program for, we're looking at really passive means. So we're not that interested at this moment in terms of discussing actual heating and cooling solutions. It's more to do with how the building might be designed. But this, the climate matrix gives a good overview of what the climate is like. Now, the climate energy index is more involving. In this case, it actually tells you how much, as a ballpark, energy, or kind of energy, how much you'd have to use energy to create an environment, assuming a thermally comfortable environment at different times of the year. But also, it also is able to, again, compare the kind of energy performance requirements you might need in different climates. So it looks at your climate and locates it in relation to other climates around. But again, we're happy to develop that further in the Q&A session. But generally, again, what is good is it's very visual, and it gives students a direct link to what's happening in terms of climate, and indeed in their future work, how they might look at what energy solutions are available. Right, so that was the climate module. So they have this worksheet which says, take in your model, download a climate file, and then do these analysis. So the first was to look at, as I said, the climate. But this this sheet that you can see next, hopefully, let's go. Now we're going to go back. Compares two different climates. So you can see that the images to the left are in a much warmer climate than the images to the right. So by choosing different locations, students can immediately get a visual feel for what the kind of climate characteristics are, and indeed what the energy performance issues might be in both of these different climates. Okay, moving on. The lighting analysis is much more involving. What is very good about IES is that it allows you to have a stereographic viewing of the climate, and it's able to use the kind of standard conventions that we're already used to in terms of lighting. So there's the sun path, and what you can do is by taking in the model, same model, you can then put in the data for the location and the climate, and you're able to plot very literally on an hourly or even a minute-by-minute basis what the sun would be doing. This is actually the Suncast tool within the lighting program. If we had the video, you could actually take the video and it would show you how the shadow moves across the building over the period of a day and over the period of different times. What students quite like about this is that they can actually decide the equinoxes, where the sun is at its lowest or its highest, as well as the midday situation in terms of lighting performance. So it's that ability to do a bit more than you would do if you were calculating it yourself. You can actually use the, if you like, the mathematical powers of the model to really look at what your building is doing in terms of lighting and shade. When we were developing the actual, if you like, beta model and the models, the models that students could use, we also had a model with an obstruction. So you could see, for example, in a place like Glasgow or other areas where there's a lot of buildings, you can actually model the buildings and you can see the effect of shade on your building. Also, we used the so that's it in it would have moved around if it was a video, but that you can actually create a mini video, you can do all sorts of things, but students very much like the whole visual nature of this to see what's happening. But the other lighting tool that we use within, or we chose to use within IES, was FluxDL. Now that one is looking at the daylight factor, or FluxDL looks at the daylight factor within the building. And what it does is quite sophisticated. It maps the room into small squares and calculates a daylight factor for each of those. And you can see it gives you a very interesting pattern in terms of where the lighting is most likely to be the highest and so on. This model, I should have said, has a clerestory ceiling, which is why you see the circular bit here, but most of the lights, surprise, surprise, are where the windows are. Aside from that also, you do have printed information or printed statistics or figures which tell you what the average values are. So in terms of actual statistics you might need for a design project, you can actually say, well, at this point, the daylight factor is going to be X, Y, Z, and so on. So again, it's a very good tool, which I guess reduces a lot of the, the hard work in terms of calculating that used to be the case. But also, I think it gives a very good visual connection with what's going on. Right. Right, so the last of the themes we thought we would look at, so we looked at climate, we've looked at lighting, it was the thermal analysis. Now that's the most involving, and in a way actually that's the strength of IES VE. So what we wanted to do was to, if you like, give a gentle introduction to students about how this works. But again, it uses the same format. We've got the model. We need to be sure we've got the correct climate file inside, and then we go into what's called the IES VE program, which is called, just a minute, Apache, and then we go into the MacroFlow program. But Apache is the program you start off with to get your climate information in and to do the initial simulation. Now, it's quite involving, and this involves quite a step-by-step take you through the tasks process, but effectively we tried to again create some models there so the students didn't have to do as much as they would have to if they were doing it on their own. So they could effectively take say the model with the obstructions. We had about 5 different modes. One was with the windows all closed, one was with the windows 50% open, and one was with the windows 30% open. But they could also, for example, change the profile of the cladding. So you could have either a high you value, so a very well-insulated building or a very poorly insulated building as well. So apart from the window condition, you could also look at the performance of the materials that the building was designed to do. So with the idea would be to try and choose one characteristic. So ideally, probably one would start off with the window openings and so on. You've got the right climate, same climate, you change the window openings, you put that through the program, and you would come out with some data, statistics showing the heating, the likely heat, humidity, and other bits in terms of the internal condition performance of the building. But for the students, what was most interesting, I think, for them visually was to see what the airflow performance would be through the building. And that involved using macroflow. And what it would do was, when you'd got the right characteristics of the building described, it was able to do, this is the, I'm just going back a bit here, or taking you back. This is to do with the actual simulation. So by the time you've got all the information in, the simulation takes place, and you've got all the different data. So, and that's the macro flow. That's the macro flow system doing that. But when we get to this, which is back to Apache.
Yeah, that's in the Vista results.
Right. This is my colleague Ja Roderick coming through.
Sorry, jumping.
What we're able to do here, which again is, if you like, the more visual, is to be able to say what the airflow is going to be across this building at a certain day and certain time. In the corner here you can see its date and time, which is the 21st of June, and it's at 2:30 in the afternoon. So again, you could have a sequence or series of these models showing exactly how your building is going to perform with 50% open windows at a certain time and in a certain climate. So again, the visual connection was the interesting bit. But the using macro flow to put the information in and being able to look at the data also is important in the sense that students are able to get a better connection again with the kind of figures that environmental performance engineers will be discussing with them when they're in real life projects. So it's a taster of what the full force of IES would be, but in terms, it's being very moderated to the needs of students and learners, particularly in terms of both using actually thermal modeling programs, but importantly for us in terms of pedagogy, it's connecting kind of key principles like lighting, airflow, and indeed climate to the students, using the model as a tool as another tool and teaching package. And the nice thing about it was that we did end up with about a 25-page program, 25-page notebook, sort of saying this is how you do it. So the idea is that they can use it as a self-teaching tool, or it could be used in a teaching environment. Right. So that's what we did. Once that was complete, we had a series of meetings at IES in Glasgow where we tested what we came up with and trialed it. Lisa Moffat, who's not here, was our kind of test student, and Gillian Treacy, who's also not here, did a lot of the lighting, finessing the lighting tasks and exercises that we used. Once we'd finished that, we then contacted a number of universities and one SME. We actually visited 4 universities: Liverpool University, the Mackintosh School of Architecture, the University of Strathclyde, and obviously ESALA, which is where we are from. Lisa Moffat was able to test the model in her third-year design class. The feedback was very positive. We, unfortunately, because of the timing of the project, were more able to deal or talk directly to environmental design academics, those who taught the courses in these schools, and some of their postgraduate students. So one of the tasks for the next stage of this is to actually get the students to do the test runs, because at the timing, it was very important that it was time to work within their design year, and by the time we'd got the program tested and ready to run, the design year had started. But we had very fruitful conversations with staff members. We also have connections with Dublin Institute of Technology, and I have been in contact with Archial, who are an SME, who we might be looking at developing parts of this into a CPD model. So, as I said, the evaluation, well, generally positive feedback. There still were questions, or rather there still were issues in terms of the feedback we were getting from the staff about the interface, because out of the 4 or 5 schools, all but one had heard of IES, but the interface was the problem. So in a way, that's what we had identified as the problem to begin with. We need a simple interface for architects and architecture students. So we're still looking at that. And then the issue is whether we needed as much interactivity, or whether we should just give them models and say, right, this is a model, run the program. Or we give them the chance to actually change things like the climate and so on and so forth. And another one was to do with the cross-platform usage. This is bringing us right to date. You know, most architects seem to use the Macintosh. I had a few arguments with my colleague, Ja, who is a very PC person. And it was the need to actually have a program that would work across these platforms, and indeed in the future on the iPad or whatever system that students are likely to use. And so we sort of, I guess this is a kind of resolution. There's a need to probably have a staged introduction to the interactivity. So we could start possibly with the models, and then they could then start to develop a few, be able to engage a bit with changing things. And then finally, possibly by MArch postgraduate status, actually use it for modelling. We do actually have a PhD student at the moment who's been using IES for his own PhD in terms of its modelling. So what are the SWOT? What's the SWOT? The strengths, weaknesses, opportunities, and threats of the analysis that we've done. Well, we think there's a gap in the market, certainly. An unknown company, or a company that shall not be known, has sold its equivalent program to a larger company. Therefore, support is quite limited. So we think that IES, particularly for the Scottish education, architectural education and practice market, is very good. IES is a local company. It's got very brilliant academics and has very good support. So we think this is certainly an area that could be developed. So that's the strength. We think, though, that there are new user-friendly apps, literally apps, that exist for environmental analysis, some of which are incredibly smart. So in a way, IES possibly needs to look not just at the IES Lite for education, but indeed these other apps for the iPad or the iPod or whatever it is. But again, so that's possibly an emerging weakness that needs to be looked at. However, there is the student and small and medium enterprise knowledge need, which is still to be fulfilled. So again, that's the strength. Possibly there's that issue, though, about whether you cannibalize the market, you know, which bit is for students, which bit is for small and medium-sized enterprises, because we have a teaching remit, whereas the SMEs are probably looking more for a solution to design that they're doing immediately. And then there's a question which, again, is, I guess, more technical. What do you do? Is it an add-on to the existing program, or do you create a brand new program? And if we go to the next slide, you can see that there are people who may be interested in that. The University of Edinburgh was very interested in the work we've been doing so far, and we have had a meeting since then, since the completion of the project, with another senior representative of IES, and we're looking at developing the program further. But to bridge that, at the moment, I've just been in receipt of a further fund from the University of Edinburgh to continue with the parts we haven't completed, so the student analysis, and to develop, to finalize the beta program, because we'll get to the CETA or the Epsilon. We've got to get one final version which is ready to go. So that needs developing in the next 3 to 4 months. But as I said, we are in further discussions with IES to look at larger funding, possibly FP7, that's a European funding stream. The EPSRC, well, it's the Physical and Science Research Council in the UK, in terms of getting larger funding, and possibly a knowledge exchange project is being talked about as well. So we hope to also explore our links with SMEs, so possibly Archial, who we've been in touch with. But the University of Edinburgh also has expressed an interest in possibly developing an app, an environmental design app of some sort. So that, again, will be done in collaboration with IES. So there are definitely a lot of benefits we can see for the future in terms of this initial project that we've just completed. And to round up then, we think that IES is a teaching tool for environmental design. It has certainly, in our short project period, it's been shown that there are themes and areas that we can extract and develop that will work well in terms of a teaching environment at different levels, self-teaching within a program and so on. But we do acknowledge CIC Start Online. We're very happy, and we're happy to have been part of the project. Thank you very much.
Well, thank you very much, Ola, for your presentation. We can now start with questions and answers. And there are quite a few already from our online viewers. For example, Keith Pierce asks, can you confirm that the climatic data available is worldwide and not just Europe, UK?
An immediate answer to that, but I will be passing it through to Ja as well, is that it is worldwide. We've got climate files from across the world, Reykjavik, Kazakhstan. Generally, we have all five continents are covered, but not specifically all towns, but there's certainly representative towns on all 5 continents.
Yeah, basically, if you go to the VE database, climate database, we covered quite a lot worldwide climate database. So normally, any quite common areas, countries would be covered. But if some areas or climate specifically you wanted to use it and actually it's not in the VE and climate database, you could easily just import your local climate data very easily into VE climate database. So you can use it straight away. Or you can use it Energy Plus data format, so that data can be strictly goes into the IES VE as well. So yeah, definitely worthwhile.
Okay, thanks very much. The next question is from Dapanita Das. It is known that wind speed can vary considerably depending on the buildings clustered around the site under consideration. Referring to thermal analysis, I would like to know whether the airflow unit derived considered this parameter.
Yes, definitely wind speed is one of important parameters. So that's why when you run any thermal simulations, you would look at the climate for the data first. So these for the data would be when you run a thermal simulation will be part of the thermal in simulation, and then especially when you look at using the macro flow to explore the different natural ventilation strategies. Say for example, by window the open, by opening the window, and then you can see percentage of window opening, or you can control your window opening based on your room temperature or CO2 level. So all these things actually it's largely determined by the wind speed and the wind directions. So therefore, in the macro flow package, when you control these different ventilation strategies, actually we calculate based on the wind speed. We calculate the wind pressure outside and inside the window, the rooms. Then therefore you can get quite accurate results of airflow go through your each window when you do the thermal simulations.
Thank you. The next question is from Tamar Gado, who is asking how IES education will be different from Autodesk Ecotect.
Right. This is the competitor program. The idea is that IES education in its very stripped down form could be used by your second years or your first years. Autodesk and Ecotect are still slightly more, I would say, medium level to high level programs. You need some knowledge of how models run and how to do thermal and other forms of analysis. Now, the idea about IES, I call it Education Light, is that it's literally for a complete beginner. You don't even need to know the principles of modeling. So it's supposed to really take the student hand in the hand and take them through the process. So we see it as being, very much, I guess, basic entry. But certainly the competitor would be Ecotech, because with Ecotech you have to, it's more or less integrated into using ArchiCAD and AutoCAD. With this, Google SketchUp, most people can learn in an afternoon or a week, and they can immediately begin to use their basic models within the IES environment. So it doesn't require a lot of prior ability to be able to use it successfully. Or we expect that's what the education version would do.
Again, question from Tamer Gado, who works at the Dundee School of Architecture. And he is asking how IES education can fit within the architecture education process in the UK, and how you will convince the undergraduate students to use it.
What we do, or what we have done in the past 5 years in the architecture school, first of all, what used to be Edinburgh College of Art and now within the university, is to use it as part of the teaching program. It's not a standalone, it works within environmental design, and a lot of the students actually then begin to use it within their design projects for some parts of analysis. So we've never said this is all you have to use, but what we have said is here's a program that can help you investigate things. And particularly because it's got such a visual connection, the lighting is an area that a lot of students use for their daylight factor analysis and so on. So I think it has to do with the way in which you integrate it into the architectural education program. And do remember that some of the Architects Registration Board guidelines are technology and environment. So it is a tool that is valid within the curriculum as it stands. And what we haven't discussed, of course, is the fact that it ties into sustainability and energy issues as well, which is another area that we're going to develop further.
And also, I think when we look at the current the way for the architectural design approach, so probably most common we do is the linear design approach. I think in the future, in the short future, going to be people going to more focus on the BIM approach, BIM way to do it. So that's actually requires architects to be able to get involved with the simulation in a very early stage. So that's something actually. When we look at the teaching, so that's students need to be aware what kind of the skills they need to learn, and then raise up this awareness where when they grown up, when they graduate, so they can bring this kind of skills and awareness into their design work. Yeah.
Additional question from Tamer Gado. With regards to the solar analysis, how IES will be different for the students from what SketchUp model can do that they will probably already have?
The IES model is more involved. You can actually, as I said, a day, a time, a place. With SketchUp, it gives a much more, it's normally a 24-hour analysis. There's less in terms of climate. So for example, your lighting analysis in, say, the Middle East is going to be very different from your lighting analysis in Iceland. So to be able to use the climate files as well as the lighting situation in terms of the ways in which the light goes through gives you much more. And you're able to actually take a snapshot in terms of having the actual statistics and the data there as well. So much as I say the visual is important, IES, if you like, is a serious program as well. It will give you the statistics and data you need as well for your work.
And also the difference between the SketchUp and the IESV is IESV. It's an integrated package. It's it's based on one single module, and then you can do quite a lot parallelized tasks at the same time. So we're not looking. So apart from the climate, lighting, thermal, this package, you based on the same model. Actually, you can explore more. You can in the later detailed design stage and stage, you can actually bring the compliance with the regulation and other stuff in as well. So rather than you pick up the one tool, do one job, and then you have to swap to the different tools to complete the rest of the task. So the VE is kind of one tools which is embedded with the different functionality. So you can carry on the design from early design stage to the detailed or to the completion.
More questions from Tamer. Did you consider the acoustic analysis?
Yes, we are. So because that's a good question, because at the moment the VE, I think VE strength is mostly focused on the thermal package or environmental analysis, and acoustic actually is quite important as well. So at the moment we are actually just in the process to trying to get fundings with one of universities to try to bring the acoustic package. So actually, when people design, for example, you design a theater, apart from the thermal performance, acoustic is very important for theater, this kind of type of the buildings. So hopefully, the users can do the pipe setting. Meanwhile, they can do the carry on acoustic analysis by using the tool, which is we call integrated tools.
A question from George Alumakis. Can you insert meteorological data obtained on site, for example, from a simple weather station that measures temperature, humidity, insolation, etc.?
Yes, you can. So the standard weather file, it's based on hourly, but however, if you users have their own measured whatever the weather data, could be like maybe half an hour, whatever, or you could actually import your own climate. But in the VE climate database, the format, you have to have a certain format. You have to have normally the 6 parameters. So for those absent parameters, unfortunately, you have to fill in with the default data if you don't have it. The answer is yes.
Another question from Tamer. Why you do not just use TMY2 files of the CIC climate files?
I think that is an option, isn't it?
Yes, we have the CIC weather file as well, TRY and the DSY, the text reference here data and the summer data as well. It's definitely yes. See, in the VE weather data, we have a different type of the weather files. It's a total user option.
That's correct.
Which data it's suitable for you. In your case study, you can choose it. Yes.
Which is one of the reasons why we do like IES. In some ways, it's very flexible. Despite it obviously being trademarked to IES VE, there are various options in terms of how you can use the model. You can bring in your own material, you can bring in your own data. But in terms of what we were looking at for students, we thought it's easier actually to have just a few model climates of certain areas to use. But certainly, if you are using it on a professional basis or on a research basis, certainly you can customize the information and the data that you can put in.
A question from Huda Salman. Have you studied the potential impact of using IES on form generation? That is really on design of buildings.
Well, this is one, in our case, for students, we're really interested at this level in using IES to get them to understand basic principles in terms of environment. But yes, at a higher level, again, this is one of the parametric analysis you can do. If I change the form to a certain level, what's its performance going to be? That's why it's a model. So yes, it's certainly possible. But in terms of, if you like, the function, what we set ourselves to do in this task, it was more to do with getting it to be used as a tool for students to appreciate environmental performance, but also as a way to appreciate and, if you like, analyze their buildings or their models of their building designs. But the idea was not to use it to generate forms. But that's certainly a valid possibility, especially in research terms, and for some architectural practices, that's what they do. Yes.
Another question or comment from Huda Salman. Our Scott Sutherland School of Architecture students opt for Ecotech as IES crashes every time they run the model.
I think that is part of the reason why we're looking at an education version. It's a very big and complex model, and for what students need it for, actually, a lot of the features are not required. So this is one of the issues about what to do. Do you have it as an add-on that you run, or do you actually strip it down and have a light version? And this will be the next stage of the project. But certainly, that's part of the reason why we wanted to work with IES, because students do like it, but sometimes it's both complicated, but also it uses a lot of, because it's so complicated, it has been known to crash. There are bugs. I guess that's
just want to make a comment here. Actually, there was quite several quite good top architects firms are using the VE. So VE is very complicated simulation tools, quite powerful, but it doesn't mean it's only designed for the like engineer use purpose. Actually, we do have quite a lot, all of the work the architecture firms using it, and also in the VE, apart from the design, the package which it's all I showed you in the presentation, actually we have a navigator, because due to this teaching course, we haven't actually introduced the navigator function. So navigator, which is help you one by one steps to help you to carry through all your works, all your tasks. So yes, so look at the VE. We are trying to help make, or shall I say, just make architects' lives easier, to make it very simplified interface, but quite complete engine to do the still accurate simulation in the background. So that's definitely, so that's why as the conclusion, one of the conclusion we agreed is we try to get big European fundings. Actually, we can actually come up with a really good product based on, this is research feedbacks. Yeah. We can get some fundings, get some products, can have a light version VE, which is ideally simplified interface using a navigator step-by-step guide, and also all the complicated calculation would be behind the scene. That's the job.
Okay, here is a comment and question from Lisa Moffat, who was involved in your research. She thanks first of all for the presentation, and says this is question for Ja. Ola and I are interested in how IES might be used for passive heating and cooling in design and technology teaching. But IES was designed for designing active systems. How does this significant shift impact your thinking of how the program might be adjusted to be more appropriate for student use?
Well, this is very good. This is very good question, sir. Well, the VE is a design tool. So in these tools you have all kinds of functions. Especially we have like, as the whole presentation is covered, we have a climate, lighting, thermal, and we have a system which we haven't touched. So this HVAC system we developed quite a lot in it. So that which has helped mechanically to condition the space. But however, when I look at the passive way, so that's why when we in the navigator we have quite a lot the climate, the sustainable package in the VE, which is haven't been shown in this course. We encourage people to use the tools to explore all kinds of possibility to achieve a passive design before they go on rely on the active mechanical way, just trying to condition your space. So therefore, I mean, the climate is very important. So that's why for any design, we try to encourage people to use the design tool VE in a very early stage, to use the climate tools to explore what you can do with the given climate conditions. And then we have other tools such as building energy index, and also we have a bioclimate index as well to help you what is option if you use the passive technology to try to achieve what you can do. And then if still can't achieve the thermal comfort, and then we talk about what kind of system you can bring on in a later stage.
Okay. Yeah. A question from Nick Taylor. Has the simulation been checked against real buildings? Have you done any post-occupancy evaluation of the projects that have used IES design tools, and then compared the actual performance against the simulated or modeled performance?
Yes, that's a good question, because that's a common thing when you use any simulation tools. You can carry on very detailed simulation and then get a set of predictive data. But however, when the building is being used, is performed, and then the energy performance could be different. So yes, at the moment we have a new product just come up from research funding. We call it the smart research funding. We just nearly finished in 2 months' time. So the product called VE Scan. So basically, what you do is you can have your thermal simulation model set up in the VE. You can do all the complicated simulation, whatever. You can get all the certain data. Meanwhile, if you have the data from BEM system, or you can simplify, you can see if you have a bill, your energy bill, even monthly energy bill, or you could have your hourly data from your BEM system. All this data, the field experiment data, can be plugged in to our product called VE Scan. So that's kind of based, at the moment it's based on Excel sheet. So all this data you can plug in to the Excel sheet. So in the Excel sheet you would have your experimental data, air temperature, energy, and electricity consumptions. And then in the VE Scan you can simply just set up a few parameters, and click the button. So you can actually load your model. You've done it already. You can load your model in the VE Scan. So therefore, all your field experiment data can be imported to your VE model, and then in the right place. So in the Vista, which is when you look at the results, you can see that's the graphs you predict data, for example, air temperature or the energy consumption. And then here is the measure data from BEM system. Actually, just few seconds, you can actually plot this predict data and measure data, so you can compare. So that's actually, it's a calibration. So at the moment we can do the smaller steps, we can do hourly calibration. Yep.
Comment from Tamer Gado. Ecotech is also one tool, and the majority of the students do not want to use it. He's from Dundee School of Architecture, so there is discussion here between Dundee School of Architecture and Scott Sutherland School of Architecture on what tool is better. Here is a bit longer comment from Tamer Gado. I believe that the problem with all the simulation software in context of architecture practice and education is that they do not use the same language the architects use and do not respect their state of mind. To this end, I think that IES, education, or even Ecotech will never be popular in this context unless they change how they do things. I believe that Ecotech is much easier for the students to use, and in terms of interface, I strongly believe that architecture students will not be interested in using IES as it stands at the moment.
Well, I think it's his, Tamara, that's your opinion. I think what we are doing and what we've been able to get funds to do is to begin to change that interface. Certainly, we have students who are totally we've got technophiles and technophobes. So some are digital natives, some cannot stand the idea, some still work mainly with pen and pencil. And I've seen students change. I've seen students actually say, that's useful. I think it's to do with whether they can see, or whether, not just students, architects and those who are involved in the creative design can see the usefulness of it, of IES, and also connect with it. So this is why we look at the visual particularly, and how that can actually get students to gain the confidence to use it, experiment with it, and explore it, which I think is the nice thing about IES. There's a lot that you can explore with it, and you can customize what it is you want to do with it. So chacun, everybody to his own opinion, but I think that certainly there is a future for it in the educational market for students and for practicing architects.
A question from Giorgio Makis. Have you considered the option to model the use of renewable energy systems in the buildings?
Yes, we can do it already. So in the VE, once again, because this is the teaching module designed for the undergraduate, so that's why we decided we're not to bring up renewable technology. So therefore, as Ola mentioned previously, for this teaching module, we haven't introduced any HVAC system in it. So basically, when we look at the thermal analysis purely based on free floating, it's no system goes in. It's just based on the building itself with the external air, the climate conditions, and then we try to look at different natural ventilation strategies to see how this, by passively open the window, look at different climate, conditions, how actually in a very early stage can help the students to understand or give the students indication for their design. So yes, for the renewables, you definitely CHP, wind turbine, solar panels, all this PV can be done, can be simulated, can be done in the VE. It's integrated with the building site as well.
Will the module on the use of environmental design tools be an optional module, or will it be a compulsory module at the School of Architecture at the University of Edinburgh?
We would see it as being part of a technology and environment course. So it would be a tool or a the model would be part of the course tuition, but students would not be forced to use it, but I guess they'd be taught it, and they would have some assignments in it, but we're not saying you must use IES, but certainly we see it as being part of a suite of teaching tools that we would use for students.
Mm-hmm. Again, Tamer wants to engage in discussion. Do you have previous work that supports your argument that IES has future in architecture education and practice, or that is your opinion?
I certainly have students who have gone on, some of them have now graduated, who had used IES in its clunky version about 3 years ago and had used it as part of their design thesis, particularly to explore daylight factor and lighting. So there is evidence of students who have used the program. So that's the hard and fast evidence. But part of the reason we're doing this as a consultancy and a research project is to explore this further and to see what students would actually use.
And from the firms like architecture firms, as I mentioned earlier, we have quite a lot of architecture firms using the VE. Actually, recently, my colleagues just flew to US, one of the top architect firms. They used the VE. Actually, they asked us to give them internal training for like 3-4 days internal training. So it's definitely the market is, we are having quite a lot of architect users, and meanwhile we are trying to make our interface simplified for the architect users. Yeah, it's still ongoing, so we're not stopped. We're still trying to. Things is changing. Different release, we have a different features interface. So yeah.
Well, I will just read a series of compliments from Dave Tremolin. One of the best presentations I've seen on CIC Start Online. From Keith Perth, nice presentation, well worth the time, thank you. From Tamer Garo, I second Dave, this is very good presentation, thank you very much. However, we have not finished yet, we can ask more questions because we still have time. So I have a few questions. Could you tell us more, Ola, whether students were interested in using this tool? Did you just work with one student, or did you show to a group, or how did they engage?
What we did, because we haven't yet done the full student survey, but Lisa was involved in using it with some of her students in Sala, and as I understand it, it was the whole class that could use it. But this is the next stage we're going to, where we're going to actually get. Ideally, what we're hoping to do is to do a session as part of, within a technology and environment teaching course, and then get the students to be allowed to use it afterwards, and then they can evaluate and see how they feel it's worked for them. So they would have a session with myself, or possibly Gillian Treacy, who's I've got funding for, to work with for the next 3 months on it, and then we would leave a copy of IES, because IES has been very, very generous. They're happy to give a copy to each of the schools of architecture, and they would then have time to, if you like, play with it and use it themselves. These are the students who we'd already have introduced the program to, and we're going to attach a SurveyMonkey questionnaire to the end, so they can then send us back their evaluation. And we could possibly have a focus group discussion at the end of the period as well, to get group comments as well.
There is a series of more compliments from several viewers on the presentation, but I just wanted to ask one question. Yeah, could you tell us how this collaboration will further impact on development of IES tools? Do you see it as a helpful initiative?
Definitely. I mean, For us as software vendors, when we come up with some new features or products, we need to know exactly what's going on in the market. We need to get the right signals, right information. So I think the CIC funded project is very good because at least we know this is the problem. I mean, it's not only for IESV, it's for every software vendors to be able to let architecture students or architects feel comfortable to use a tool in their design process. It is a challenge job. So for us, we want to push the software definitely into this direction. So the outcomes, the feedbacks from the students, from all that work is very valuable. So actually, it's kind of give us a good indication, like especially from visualized, so we would know exactly what they want to see, what kind of things is maybe too complicated, the level. So it's very good feedbacks, and it's a good indication for us to take on as the next level to develop a further, the could be light VE for architects.
I think I'd also like to add that I think collaboration really is a very good way to work. It's been a very good collaborative process because neither of us had really met it ourselves. Well, neither my group, if not my team from Asala, nor the IES group had contact with Edinburgh University at this level before. So we really didn't know what was going to happen. And as I said, I came in with the conception that we could reconstruct a program in 6 months. And the things we have both learned in the process of going through this. And I would really, again, like to thank CIC for giving us this opportunity, because it would have been much more difficult to go through the normal funding processes to get to a situation where you get 6 months to do something. And I think what's been good is that procedurally it's moved on now to looking at larger projects, which has to be a good thing. So I think we both benefited. We've had some idea about the way in which IES as a business performs, and hopefully they have some idea as to how, I guess, the quirky architects and architecture students learn. So I think it's been a learning process.
Here we are. Again, question from Lisa Moffitt. I should clarify Ola's comment that IES was included in my design teaching. We were not able to expose students to the program because it is currently not installed in any computers at the university. Until the interface, well, I have lost connection again. We'll see whether we can continue. Here is a comment from Lisa Moffat again. Until the interface is streamlined, it more clearly foregrounds passive strategies and broader context, landscape, etc. Its utility in Design Studio is limited from my perspective. I see it as being more promising with technology teaching as a way of facilitating visualization and testing of some of the concepts introduced through lectures. We also had some comments and suggestions from, a comment from Tamar Gado, who said that there are lots of people who are interested in the topic, and if we could distribute the contact of the online guests to facilitate networking. I believe that you can currently see on your screen who is attending the event. If we receive confirmation from our online viewers that they are happy to share their contact details, we will do that. I think that would be the way to proceed. Let me check if there are any more questions. No, this is something. Well, Tamar acknowledges and thanks for this assistance. And it seems that others will be happy to share contact details. We'll follow that up anyway. If there are no more questions, well, I just wanted to ask one more, Ola, about your collaboration with industry. Has this project helped you in establishing links with architectural practices, and whether you plan to develop further the program to maybe develop it as a CPD, continuous professional development tool for architectural practices?
Yes, we certainly, we've already, as I said, been in touch with Archial, but we are looking at that as another area of development because certainly we think some of the issues that students have are some of the issues that particularly smaller architectural practices would have, who probably can't afford to have the whole IES package as well. But also in terms of continuing professional development, again, environment and environmental issues are a major topic. So we think there's certainly a future in that area, and we will be making more contact with small and medium-sized enterprises in architecture.
Okay. Well, there are no more questions from our online audience. I would like to thank everyone who has participated and contributed with questions. And first of all, I would like to thank our speaker, Ola Uduku, and her colleague, Ja Roderick from IES Ltd for contribution in the discussion.
Thank you.
Before we close, I would just like to attract your attention to our live conference, the next event that we are organizing here at Glasgow Caledonian University. The title of the conference is The Green Deal and Sustainable Refurbishment of Traditional Buildings. This is a whole-day live conference, and it will take place on Wednesday, 29th of February. Historic Scotland is the exclusive sponsor of this event, and with their sponsorship, we are able to offer a delegate fee for only £50. Initiatives like the Green Deal are set to encourage interest in refurbishment. However, what do we know about energy performance of existing buildings? How can refurbishment be carried out effectively and sustainably? What guidance is available? What are the real and perceived risks? Historic Scotland, for example, has commissioned research over the last 5 years which attempts to address these issues. Research undertaken at universities will be presented. Historic Scotland and building professionals involved in refurbishment projects will offer their perspectives. There will be no live stream from this conference. It will not be transmitted online. So if you wish to attend, you will have to attend in person. And please do access our website to see the conference program, who the speakers will be, and to book places. We look forward to welcoming you at our forthcoming events, first of all at this conference and then future webinars. Thank you very much for watching.